Hello, today we are going to review solving simultaneous linear equations, otherwise known as systems of equations. So there are three ways to solve simultaneous equations. There's solving by graphing, solving by elimination, and solving by substitution. Today we are just going to look at solving by elimination. We're just going to review that. So, in order to solve by elimination, we want to eliminate one of the variables in both equations. We do this by getting the coefficients of one of the variables to be the same number but the opposite sign, and we then add the two equations together. One of the variables will cancel out, and we can solve for one variable and go from there. You'll see what I mean by that in this next example. So, this first example, we have two equations here. We have negative 4x minus 2y equals negative 12, and 4x plus 8y equals negative 24. So, we want to make sure that when we add these two equations together, one of the variables will cancel. In this case, we notice right away that we have negative 4x and positive 4x. So the coefficients on these x variables are the same number but the opposite signs. So this means that if we add these two equations together, the x variable would cancel automatically. So let's go ahead and do that. So we'll add these two equations together. So, we notice that this negative 4x and this positive 4x cancel, because if you do negative 4 plus 4, you get 0. So those will cancel, and then we can add the two other components of the equations. So we get negative 2y plus 8y, which equals 6y. And then we do negative 12 minus 24, and we get negative 36. So we can solve for that y by dividing both sides of this equation by 6. So we divide this side by 6 and this side by 6. So we get y equals negative 6. So we're not done yet. The important part of solving for systems of equations is to make sure that you solve for both variables. So we've solved for y, but we still want to make sure that we solve for x. So in order to do this, we just pick one of the original equations up here that we have, one of these two, and we take that y equals negative 6 and plug it in. So we take that negative 6 and put it wherever we see a y. So pick either equation you want. I picked the bottom equation, so I take that 4x plus 8y equals negative 24. I just take this negative 6 here and put it wherever I see a y. So I get 4x plus 8 times negative 6 equals negative 24. Then we just simplify that, so 8 times negative 6 is negative 48. So now we have 4x minus 48 is negative 24. So we just continue with simple algebra here. We just add that 48 to both sides of the equation. We're left with 4x equals 24. Divide both sides by 4. And we get x equals 6. So now we have both variables. So we've solved the system. So we just put this into what's called the coordinate pair form. So x comma y, just a coordinate pair. So we take this x comma y, and we're left with 6 comma negative 6. So that's our solution. So that is where those two lines, if these were to be graphed, that's where they would intersect. That's where they would cross. So, now let's look at another example. An example that requires one extra step. It's not too bad. So we just do the same thing. So we look here and we notice that we don't have the convenience like we did last time. We don't have the same number but opposite sign in either of these variables. So we just have to do one extra step. We just have to multiply one of the equations by a number to get one of the variables to cancel. So we can do this with either variable. We can do it with either x or y. I'm going to choose x, so it just seems easier to me. So we have this negative 4x and this x. So we want those variables, if we want them to cancel, we want the coefficients to be the same number but the opposite sign. So we want this x to be the same number but opposite sign as this negative 4x. So we just take this whole equation down here, we multiply it by 4, because 4 is opposite of negative 4. So if we multiply this x by 4, it'd cancel out with that other x. So the key is to multiply the whole equation by that number, all parts. So we just rewrite this first equation here. We take the second equation and multiply the whole thing by that number, all three pieces. So we just distribute that through. So I like to rewrite both equations to keep it organized. So I rewrite that first equation, and then I just distribute that 4 through. So I get 4 times x is 4x, 4 times negative 3y is negative 12y, and 4 times 6 is negative 24. So now we notice that we have a set of variables that would cancel out. So now we can add these two together now that we make sure that we have variables that cancel. So we just add these two like we did in the first example. And now we have those x's cancel out because negative 4x plus 4x is 0. So we just put a line through it. And we add the two other parts of the equation. So we get 9y plus negative 12y. So we get negative 3y. And 9 plus negative 24 is negative 15. So we just divide both sides by negative 3, and we get y equals 5. Now, just like the last example, we can't forget we have to solve for both variables, so we have to plug this y value into one of these original equations again. So we just take that 5 and we plug it in. So we take this equation, you can choose either you want, I chose the first one. We get negative 4x plus 9y equals 9. So we just take this 5, put it wherever we see a y, and we get negative 4x plus 9 times 5 equals 9. 9 times 5 is 45, so we're left with negative 4x plus 45 is 9. Subtract that 45 from both sides, just keep doing your algebra, and you get negative 4x equals negative 36. We just divide both sides by negative 4, and we get x is 9. So we just put that in coordinate pair form like we did before, x comma y, and we get 9 comma 5. So if we were to graph these two equations on a coordinate plane, 9, 5 would be the point where they intersect. I hope this helped you. Thank you for watching.